Hello. Today we're here to demonstrate post-quantum encryption using an ID Quantique daughter board installed on a standard Raspberry Pi computer. Now this daughter board has a photon device in it which creates true quantum entropy. And that has been developed specifically to work with Secure Channel's exotic encryption system as a way to create stronger type of encryption. Now what will happen is we'll put an external USB stick with some media on it, maybe movies or images, and it will go through the device, it will encrypt, and the device will upload that media directly to the cloud where we can fetch it again and show the decryption process on the other side. For this demonstration, there are two prerequisites. One is that this device must be Wi-Fi connected so that it can communicate with the internet and upload. And two, we recommend downloading our free ZipCrypt tool off the web, which we'll show you here in a moment, so that you can consume and decrypt the files on the other side once they've been sent. So without further ado, we will show you the place to get those downloads.
To decrypt the information that's sent from this device, you will require ZipCrypt, a free tool provided by Secure Channels. You can get it by navigating to beta.skipcom.com and navigating to the download section. From here, you go down to the download trial button, follow the standard process for downloading and installing an application, and just like WinZip, you will be able to right-click on any file to simply decrypt it or compress it.
Here you will see that Secure Channels program is installed under the folder /opt/gbb5, where the actual program is called gbb5.jar. On this system, we have installed a standard Java runtime environment 1.8 under 231. That is required to run the program gbb5.jar. In addition to the standard method of executing a jar file from the command line, we have included a shell script gbb5.sh, and the program can be started simply by typing /gbb5.sh and running the program. You will notice that there is a staging folder which is required, and log files will be deployed into the folder opt/logs. Now, there's one additional file in this folder called email.config. Email.config is a simple text file, and you can see it has a single email recipient. This will be the person that receives the encryption link during the demo. By default, when shipped, this will be configured to thomas.stengel@idquantique.com. It can be changed at any time, even while the program is running. To run the program again, type /gbb5.sh. When the program starts, log data will appear directly on the screen. If everything is working correctly, you will notice the word A-OK displayed on the screen. At this point, the program is listening for USB input and is ready to accept external files. We are now transferring to a laptop computer, which is recommended as part of the demonstration as the source or origin of your media. So here we've connected an external USB stick named media into the Apple laptop that's being displayed. We will place our sample data, the one that we wish to encrypt using the ID Quantique device, into this USB stick. It should be known that when the program is completed, the USB stick will be cleared and erased, ready for another use. So the once processed image.jpg as displayed here will no longer exist on the USB stick. Also important to know, the operating system and the format of the USB stick is MS-DOS FAT. And that is done for maximum compatibility across Windows, Unix, and Apple systems. Raspberry Pi can read other types of operating systems. However, there could be problems with read-only file system if it's not supported by the Raspberry Pi. For that reason, we recommend using this USB stick during the demo. Another important feature is the name of the USB stick. The USB stick is named in all caps, media. This is important because the Raspberry Pi will recognize the volume mounted when it's connected as media/pi/media. If you do choose to use another external device, please be sure to name that device's drive media in all caps. We'll now go ahead and eject this media drive so that it can be placed into the Raspberry Pi. Switching back now to the Raspberry Pi, we're about to insert the media stick into the Pi. It should be known that any number of files can be used. For the demonstration, it's probably best to use one single file just to keep things simple for your audience. There is no theoretical maximum to the size of files that you can put through here. However, you might be gated by the upload transfer speed to cloud. For that reason, we don't recommend exceeding 100 megabyte files. The ideal demonstration for a conversation like this one is about a 5 megabyte image file or so. So now we're going to connect the USB stick, and within 5 seconds, you will see the program respond and begin processing. While you're explaining this to a customer, you should be aware that there are 3 steps in this process. Step 1 is encryption, and you'll see that the image file here is being encrypted, and the amount of time required for that encryption is displayed, and the random strength setting is also displayed. More on that in a moment. The second aspect of this is the actual upload to the cloud. The larger the file, the longer this will take. This generally takes a lot longer than encryption on big files. The third and final step is the transmission of keys. For this demo, keys are transmitted in plain text as a zip file directly as an email attachment to the intended recipient. After the keys have been transmitted, the intended recipient should check their email box. Here you can see I've opened up Outlook email client, and I have received an email from the ID Quantique Raspberry Pi device. The email comes from no reply and has the subject line IDQ keys, as well as the name of the encryption key file. We'll open this email. By the way, if you don't see this email timely, please be sure to check your junk or clutter folder for the same. The content of the email is as follows. Attached to the email are encryption keys, which can be copied directly onto the desktop, as well as a hyperlink with the exact content that was encrypted. We'll click on the hyperlink to download the encryption content. Please be sure to put your encryption content, which ends in .exotic, in the same location as your keys. The encryption keys are initially sent as a .zip file to prevent email filter blocking. You will need to unzip the keys in order to use them. Unzipping can be done with a common utility such as WinZip, WinRAR, or even Windows itself. Once ready, you should see 2 files, your encryption file and the key file. If you have installed ZipCrypt on a Windows operating system, these files will have icons as displayed on the screen right now. If you do not have ZipCrypt installed, you will not be able to proceed further from this point. There is no version of ZipCrypt for Mac at this time. Next, we will double-click on the .exotic file to decrypt, and we should recognize our original content returned to us in its correct format. And this can be a movie, or it can be images, or it can be any type of file, PDF, or document. The next thing that should be done to directly exhibit the entropy that was created by the ID Quantique device is to inspect the key file. And to do that, you'll need to right-click it and open the key file with any text editor. We recommend Notepad or Notepad++. When you look in the key file, you will see the result of quantum random number generation. Now, these quantum random numbers may change in size because we have preset exotic to encrypt at various dial strength. It's random what strength exotic will encrypt at. At its base level, it will be 512 bits of encryption, which is representative of 8 64-bit QRNG numbers generated by ID Quantique. The dial setting effectively doubles at every increase, and this program uses randomly dial settings 1 through 5. This particular key material is what is relevant to the conversation and generated by IDQ. At this point, the USB stick is empty, and the demonstration can be repeated as necessary. Thank you very much.
This demonstration is intended to showcase the capabilities of quantum random number generation and quantum encryption working together. Of course, best practices in key management is intended to be followed at all times. Thank you for watching.